Have you ever just stopped for a second to think about the invisible world that's humming all around you? I don't mean the air you breathe. I mean a constant, silent, super high-speed conversation that is happening right this second, connecting pretty much everything. It's like the hidden architecture of our modern lives. Just think about that invisible stream of data that's connecting your laptop to the entire internet. Yeah, the one that's probably delivering this explainer to you right now. Or what about those silent signals beaming down from satellites, way out in space, guiding you turn by turn to wherever you're going? We do it now without a second thought. And of course, there's the message that just zipped from your friend's phone to yours in like a fraction of a second, flying across miles as if it were actual magic. I mean, it really does feel like magic, doesn't it? But behind all that magic is some of the most brilliant science and engineering on the entire planet. So the big question is, how does this constant, invisible conversation actually happen? Well, the answer comes down to one single, totally fascinating field that is dedicated to solving this exact problem. How do you get a message from here to there perfectly?
And that discipline is called engineering communication. Its entire goal is right there on the screen, to reliably transfer information, your video stream, your location, your text message, from point A to point B. And here's the really crucial part, even in the presence of noise and interference. Because, electronically speaking, the world is a very noisy place.
Okay, now this slide is where it all just clicks into place. Just imagine you're trying to talk to a friend across a really loud, crowded room. Your voice? That's the transmitter. The air between you two? That's the channel. All the other conversations and the music? Yep, that's the interference. And your friend's ear is the receiver, trying its best to decode what you just said. Engineering communication? Well, it's the science of making sure your friend hears you perfectly clear despite all that racket. So how do engineers actually build these systems that can win the battle against all that noise? Well, it turns out, whether it's the Wi-Fi in your house or a deep space probe sending signals back from Mars, they all follow the same basic blueprint. And here it is. This is that blueprint. We call it the communication chain. It starts with an information source. That's the idea, the thing you want to send. The transmitter, think of it like your Wi-Fi router. It converts that idea into a signal. Then that signal travels through the channel, in this case, the airwaves. On the other side, a receiver, like the antenna in your laptop, grabs that signal, decodes it, and delivers the information to its final destination, your screen. It's simple, it's elegant, and it's incredibly powerful. And believe it or not, this simple 5-step blueprint is literally the engine of our modern world. It's working for you in dozens of ways every single day, most of the time without you even noticing. I mean, just stop and think about it for a second. Your 5G phone, the Wi-Fi at the coffee shop, the Bluetooth headphones you might be wearing right now, the GPS that got you there. Every single one of these is a masterpiece of engineering communication. They're all constantly solving that noisy room problem, but on a massive global scale. And the scale of this whole thing, it's just mind-boggling. By the year 2030, it's projected there are going to be 75 billion connected devices on this planet. 75 billion. Tiny conversations, all happening at once, and all managed by these same principles. So, to make all of this happen, what are the rules of the game? What are the core goals that engineers are always chasing? So here's the thing you have to understand. It's all a delicate balancing act. Engineers are constantly juggling these goals. They need to maximize data speed, so you get faster downloads, right? But doing that can often introduce more errors. So then they have to minimize those errors to make sure your message arrives perfectly. And they have to do it all while using as little power as possible. That's what keeps your phone's battery from dying in an hour. It is a constant, complex game of trade-offs. When you really step back and look at it, you see our entire connected world is built on these rules. Every single time you send a text or stream a movie, you're basically witnessing this invisible, high-stakes game being won for you, instantly. It really makes you wonder, what's the next great conversation we're going to engineer?